I want to ask you something, and I want you to think about it honestly. When did you last feel strong? Really strong. Not just functional, not just able to get through the day, but genuinely physically strong, the way you used to feel. When carrying groceries was nothing, when getting up from the floor was automatic, when climbing a flight of stairs did not require a second thought. For many people over 70, that feeling of strength has been fading so gradually that they barely noticed it happening, until the day they could not open a jar, or struggled to get up from a low chair, or realized they were holding the railing on stairs they used to take without thinking, and the explanation they were given, or the explanation they gave themselves, was simple: I am getting older. This is just what happens. And to some degree, that is true. But here is what most people over 70 have never been told. The muscle loss you are experiencing is not simply the inevitable result of aging. It is being actively accelerated by specific things that are happening in your body and in your daily life right now. Things that have names, things that can be understood, and things that in many cases can be meaningfully addressed. I am Dr. Daniel Chen, and today I want to explain what is actually destroying the muscles of adults over 70. Not as a vague story about getting older, but as a specific, biological, and in many ways reversible process that deserves to be understood by every person in this age group. So let us start with the basics. What actually is muscle? And why does it matter so much after 70? Muscle is not simply the tissue that allows you to move. Muscle is a metabolically active organ that plays roles in the body that go far beyond movement. Muscle is the primary site of glucose disposal in the body. When you eat carbohydrates and your blood sugar rises, it is primarily your muscle tissue that takes up that glucose and uses it for energy or stores it as glycogen. This is why muscle mass is directly linked to insulin sensitivity, and why muscle loss contributes significantly to the development and the worsening of type 2 diabetes. In older adults, muscle also serves as the body's primary protein reservoir in times of illness, injury, or metabolic stress. The body draws on muscle protein to fuel recovery and immune function. This is why older adults with low muscle mass recover from illness and surgery so much more slowly, and so much less completely than those with better preserved muscle. Muscle produces signaling molecules called myokines during contraction that have anti-inflammatory effects throughout the body, that support brain health, and that reduce the risk of several chronic diseases, including certain cancers. And muscle is the primary determinant of your physical function, your ability to walk, climb, rise, carry, balance, and recover from a stumble before it becomes a fall. Every one of these critical functions depends on muscle, and every one of them is threatened by what I'm about to describe. Now let us talk about what is actually happening to muscle after 70. The condition has a name. It is called sarcopenia, from the Greek, sarco meaning flesh, and penia meaning loss. Sarcopenia is the age-related progressive loss of muscle mass, muscle strength, and muscle function. It is now recognized as a formal medical diagnosis with established diagnostic criteria, and it is one of the most significant and most under-recognized health conditions in adults over 70. Research suggests that muscle mass declines by approximately 3 to 8% per decade after the age of 30. But this rate of decline accelerates significantly after the age of 70, with losses of up to 15% per decade or more in the most severely affected individuals. And muscle strength declines even faster than muscle mass, because the quality of the muscle, not just the quantity, also deteriorates. The muscle fibers that are lost preferentially are the fast twitch fibers, the type 2 fibers that generate rapid, powerful force. These are the fibers that catch you when you stumble, that power you up from a chair, that generate the quick, forceful movements that protect you from a fall. When their loss is advanced, the kind of rapid, reflexive strength that older adults need most, in the moments when they need it most, is exactly what is no longer there. Now let us talk about the specific factors that are driving this muscle loss after 70, and why understanding each one matters for addressing it. The first factor is the decline in anabolic hormones. Anabolic hormones are the hormones that promote building and growth, including muscle building. As we age, several key anabolic hormones decline significantly, and their decline directly accelerates muscle loss. Testosterone in men declines at approximately 1 to 2% per year after 30. By 70, many men have testosterone levels that are 50% or less of what they were at peak. Testosterone is critical for muscle protein synthesis, the process by which muscle fibers are built and repaired. When testosterone falls, this process slows significantly, and the balance between muscle building and muscle breakdown shifts toward breakdown. In women, the decline in estrogen during menopause has significant effects on muscle and bone. Estrogen supports muscle function and the inflammatory balance that maintains muscle tissue. And the loss of estrogen protection contributes meaningfully to the accelerated muscle loss that many women experience in the decade following menopause. Growth hormone, which is produced by the pituitary gland and which drives tissue growth and repair throughout the body, declines by approximately 14% per decade after early adulthood. By 70, growth hormone secretion is a fraction of what it was at 20. And this matters for muscle because growth hormone stimulates the liver to produce a secondary hormone called insulin-like growth factor 1, or IGF-1, which directly promotes muscle protein synthesis and muscle fiber repair. As growth hormone falls, IGF-1 falls with it, and the repair capacity of muscle falls accordingly. The second factor is anabolic resistance. This is one of the most important and least discussed aspects of muscle aging. After 70, anabolic resistance means that the muscle of an older adult responds less effectively to the signals that normally trigger muscle protein synthesis, specifically to protein consumption and to exercise. In a young adult, eating a meal containing adequate protein triggers a robust surge in muscle protein synthesis for several hours after the meal, during which the muscle is actively building and repairing. But in an older adult, the same meal, the same protein, triggers a much smaller and much shorter muscle protein synthesis response. The signal is there, but the muscle responds less efficiently, less powerfully, and for a shorter time. This anabolic resistance means that older adults need more protein per meal, not less, to achieve the same muscle building response as younger adults eating smaller amounts. Research consistently suggests that older adults need approximately 1.2 to 1.6 grams of protein per kilogram of body weight per day to support muscle maintenance, and that protein should be distributed across meals, with each meal containing at least 25 to 40 grams of protein. To overcome the threshold at which anabolic resistance significantly reduces the response, most older adults are eating far less protein than this and distributing it poorly. A small amount at breakfast, the largest amount at dinner, rather than spreading adequate amounts across all three meals. The third factor is chronic low-grade inflammation. This is called inflammaging, a combination of the words inflammation and aging. As we age, the immune system gradually shifts toward a state of chronic, low-level systemic inflammation that is not triggered by infection or injury, but that persists continuously at a low level in the background. This chronic inflammation is driven by multiple factors, including the accumulation of senescent cells, old cells that have stopped dividing but that release inflammatory signaling molecules called the senescence-associated secretory phenotype, increased visceral fat, the metabolically active fat around the internal organs, which itself produces inflammatory cytokines, reduced physical activity, which removes the anti-inflammatory benefits of regular muscle contraction, and age-related changes in the gut microbiome that affect systemic inflammatory signaling. Now, here's why inflammaging matters so profoundly. For muscle, the inflammatory cytokines produced in this chronic low-grade state, particularly a molecule called interleukin-6 and another called tumor necrosis factor alpha, directly promote muscle protein breakdown. They activate pathways inside muscle cells that target muscle proteins for degradation, and simultaneously, they impair muscle protein synthesis. So, inflammaging is simultaneously increasing muscle breakdown and decreasing muscle building, a double attack on muscle mass that proceeds continuously at a low level every day after 70. The fourth factor is physical inactivity. And I want to say something honest about this because I know that many people over 70 who are becoming less active are not doing so out of laziness. They are doing so because pain makes movement harder, because balance problems make them fearful, because illness, fatigue, or the loss of a walking companion, or a gym that feels intimidating has reduced their activity, and because well-meaning advice to take it easy has sometimes made rest feel like the responsible choice. But the biology is unambiguous. Muscle is a use it or lose it tissue, more than almost any other organ in the body. When muscle is not regularly challenged through movement and resistance, it atrophies. And the rate of atrophy after 70, when the hormonal support for muscle maintenance is already reduced, and when anabolic resistance is already present, is faster than at any other time of life. Research has shown that complete bed rest in older adults can result in losses of muscle mass of up to 1.5 kilograms per week. Even periods of significant inactivity, much shorter than bed rest, can produce meaningful and lasting muscle loss. In adults over 70, that requires sustained effort over months to recover. The fifth factor is inadequate protein intake. I mentioned anabolic resistance earlier and the increased protein requirements of older adults. But I want to go further because the majority of adults over 70 are not meeting even the standard recommended dietary allowance for protein of 0.8 grams per kilogram per day, let alone the higher amounts that research suggests are needed to overcome anabolic resistance and support muscle maintenance. There are several reasons for this inadequate intake. Appetite decreases with age due to changes in hunger signaling hormones and reduced gastric emptying, meaning food stays in the stomach longer, creating a more persistent feeling of fullness. The sensory pleasure of food, taste, and smell can diminish with age, reducing the drive to eat. Dental problems, common in older adults, can make chewing protein-rich foods like meat, nuts, and legumes more difficult or painful. Social isolation, which increases after 70, reduces the social motivation to prepare and eat full meals. And medications, several commonly taken by older adults, can reduce appetite or cause nausea, that discourages adequate eating. The result in many older adults is a dietary protein intake that is insufficient to overcome the anabolic resistance that is already making muscle building harder. And that, combined with the hormonal decline and the inflammaging, creates a consistently negative protein balance in muscle tissue, where breakdown exceeds building every single day. The sixth factor is vitamin D deficiency. And I include this specifically because it is one of the most common and most correctable contributors to muscle weakness and loss in older adults. And one of the most frequently overlooked, vitamin D. Most people know as the bone vitamin, but vitamin D receptors are present in muscle tissue. And vitamin D plays a direct role in muscle protein synthesis, in muscle fiber maintenance, and specifically in the maintenance of type 2 fast twitch muscle fibers, the ones most critical for strength and fall prevention. Research has shown that low vitamin D levels are associated with reduced muscle mass, reduced muscle strength, increased fall risk, and worse physical performance in adults over 65. And vitamin D deficiency is extremely common in this age group due to reduced sun exposure, reduced skin efficiency in converting sunlight to vitamin D, and reduced dietary intake. Vitamin D levels are measured by a simple blood test, and deficiency is entirely correctable with appropriate supplementation under medical supervision. If you have not had your vitamin D level specifically checked in the past year, please ask your doctor for that test at your next appointment. The seventh factor is what is called neurodegeneration of the motor units. This is a less discussed but important contributor to muscle decline after 70. Muscle function depends not just on the muscle itself, but on the nerve supply that drives it. Each motor neuron, a nerve cell in the spinal cord, controls a group of muscle fibers called a motor unit. With aging, some motor neurons die, and the muscle fibers that they controlled are left without a nerve signal. Without a nerve signal, those fibers cannot contract. They atrophy and they die. In younger adults, neighboring surviving motor neurons can expand to adopt and reinnervate orphaned muscle fibers, compensating for some of the lost motor neurons. But this compensatory capacity decreases with age. And in adults over 70, the net result of ongoing motor neuron loss and declining compensatory reinnervation is a progressive reduction in the number of functional motor units and therefore in the total contractile capacity of the muscle. This neural component of sarcopenia is sometimes called dynapenia, the selective loss of muscle strength beyond what muscle mass loss alone would explain. And it is one of the reasons why strength declines even faster than mass in the oldest adults. Now let me tell you what actually helps. And I want to be honest about what the evidence shows and what it does not. The most powerful intervention for sarcopenia with the strongest evidence base is resistance exercise. Progressive resistance training is the only intervention that has been shown to directly and meaningfully reverse some of the muscle loss of sarcopenia, even in adults over 70 and even in adults over 80. The biology of muscle adaptation does not simply stop working at 70. It requires more stimulus, more protein, more recovery time than at 40. But it works. Research published in the Journal of the American Geriatric Society has shown significant improvements in muscle mass, strength, and physical function in adults in their 70s and 80s following structured resistance training programs. The stimulus needs to be progressive, meaning the resistance needs to be increased over time as the muscle adapts. And it needs to be regular, at least twice per week, with adequate recovery between sessions. For older adults, exercises using body weight, resistance bands, or light to moderate weights done consistently are more valuable than any supplement, any medication, or any other intervention for preserving and rebuilding muscle after 70. The second intervention is adequate protein distributed across meals, aiming for 25 to 40 grams of high-quality protein per meal. High-quality protein sources include eggs, fish, poultry, lean meat, dairy products including Greek yogurt and cottage cheese, and plant sources including legumes, soy, and quinoa. Leucine, one of the essential amino acids found in highest amounts in animal proteins and in soy, is the specific amino acid that most powerfully triggers muscle protein synthesis. And research suggests that ensuring leucine-rich protein sources at each meal is particularly important for overcoming anabolic resistance in older adults. The third intervention is vitamin D optimization, getting your vitamin D level checked and supplementing appropriately under medical supervision. To bring levels into the optimal range has been shown in research to support muscle function and reduce fall risk in vitamin D deficient older adults. The fourth intervention is reducing chronic inflammation through dietary patterns that emphasize anti-inflammatory foods, including oily fish rich in omega-3s, colorful vegetables and fruits rich in antioxidant polyphenols, olive oil, nuts, and limiting ultra-processed foods, refined carbohydrates, and excess alcohol that promote inflammatory signaling. The Mediterranean dietary pattern has the strongest evidence base for reducing inflammatory markers in older adults and has been associated with better preservation of muscle mass and function over time. The fifth intervention is ensuring adequate sleep. This is one that many people do not connect to muscle health, but the connection is direct. The majority of growth hormone secretion and a significant proportion of muscle protein synthesis occurs during deep sleep, particularly during slow wave sleep. Poor sleep, fragmented sleep, or insufficient sleep directly reduces the hormonal environment most supportive of muscle repair and growth overnight. And as I have discussed in previous videos, poor sleep is extremely common in adults over 70 and is frequently addressable with appropriate assessment and intervention. Let me bring everything together now. After 70, muscle is being lost at a faster rate than at any previous point in life, driven by declining anabolic hormones, testosterone, growth hormone, and IGF-1, by anabolic resistance, the reduced ability of muscle to respond to protein and exercise, by chronic low-grade inflammation, called inflammaging, that simultaneously increases breakdown and decreases building, by physical inactivity that accelerates atrophy, in a muscle tissue that requires regular challenge to survive, by inadequate protein intake that leaves muscle in a persistently negative balance, by vitamin D deficiency that impairs muscle fiber maintenance and type 2 fiber function, and by neurodegeneration of motor units that reduces the nerve supply to muscle fibers and the total contractile capacity of the muscle. None of these is inevitable. None of these is untreatable. And addressing them together with progressive resistance exercise, adequate distributed protein intake, vitamin D optimization, anti-inflammatory dietary patterns, and better sleep can meaningfully slow and in some respects reverse the muscle loss that most people over 70 have been told is simply part of getting older. It is not simply part of getting older. It is a specific biological, addressable process. And now you understand it. I am Dr. Daniel Chen. If this video gave you information that changes how you think about your own strength and your own body after 70, please share it with someone who has also been told their weakness is just aging. They deserve to know that there is more to it than that, and more that can be done. Subscribe to this channel for weekly videos made with genuine care for older adults who deserve real information about their own health. And leave me a comment below. Tell me what you have noticed about your strength over the past few years, and whether anyone has ever mentioned the word sarcopenia to you. I read every single comment, and I genuinely look forward to hearing from you. Take care of your muscles. They are not just for moving. They are the foundation of everything you want to do for the rest of your life.